Hello everyone. This is the Think Out Loud series where I will be taking a programming question and trying to solve it. Think out loud so that this will help someone who is preparing for programming interviews or understand the process involved in solving a programming problem. Let's go through the problem. Given an array, rotate the array to the right by k steps where k is non-negative. The most important step in solving any problem is understanding it first. So it's better to read it slowly and read it twice. Let's go through the examples given in the question. Input is an array which has numbers from 1 to 7 and k is 3, where k is the number of steps which they ask us to rotate. And the output is 5, 6, 7, 1, 2, 3, 4. Rotate one step to the right, 7 comes to the beginning. Rotate 2 steps to the right, and 6 comes to the beginning of the array. And rotate 3 steps to the right, so 5 comes to the beginning of the array. Let's try to visualize this problem to get a better understanding of it. Let's imagine this array as a circle. By rotating one step to the right, all that they are doing is switching the 7 to this 12 o'clock position and changing the numbers in such a way that it is rotated to the right. Now we got some understanding of the question. Let's go through the next example. Input is -1, -100, 3 and 99. The number of steps that it needs to be rotated is 2. The output is 3, 99, -1 and 100. Rotating 1 steps to the right, 99 comes to the beginning. Rotating 2 steps to the right, 3 comes to the beginning. From this, we are able to understand that every rotation involves taking the element from the last index of the array and placing it in the first index and shifting the remaining elements one index to the right. Let's go through the constraints provided in this problem. The length of the array can be a maximum of 10 to the power 5. It cannot be null. So this is one constraint that we can keep in mind. We don't have to do null checks for the input. And the value of these numbers range between -2 to the power 31 to +2 to the power 31 minus 1. K, which is the number of steps, can have a maximum value of 10 to the power 5. And if it's 0, we can return the input array itself. So this is one check that we can add to our program. And as a follow-up, they have provided that try to come up with as many solutions as you can. There are at least 3 ways to solve this problem. They have asked us to try it in place, that is, not creating extra space. The easiest solution here is taking the last index element and taking the input array and placing the last element index in a new array and copying the remaining elements to the remaining indexes. But this means you are creating a new array and they don't want you to do that. They don't want you to use extra space, or right now it might sound a little unclear, but as we go through this, I think things will unwind itself. Let us write the input first. The first thing that we need to do here is check the constraints and return the result if the constraints fail. So the constraints here are, we need to check is if k is equal to 0, then we don't have to perform any rotation, we return the input itself. If it's not equal to 0, then we need to rotate the array to the right. I'm going to write a for loop. This for loop will iterate k number of times. K is 1, it will iterate once. If k is 2, it will iterate twice. Now we know that we have to perform k number of rotations. The next question is, how do we rotate it? Every rotation involves taking the element at the last index of the array. And how do we access this last index element? We can have it as a variable. Input.length minus 1 will give us the last index of the array. To clarify, I'm writing this program in Java. However, any programming language, the logic remains the same. Now that we have accessed the last index element, we can store it in a variable called x. The next step is we need to copy this variable to the first index. However, there is an element which is already present in the first index. We need to shift these elements before we perform this copy operation. Y is the pointer to the last index, and we can iterate until y is greater than 0. Let me continue the problem here. For every iteration, we do input of y is equal to input of y minus 1. So we take the previous index element and copy it to the next index, and we perform this until the first index. Once this value becomes 0, the loop gets exited, and finally we copy input of 0 is equal to x, which is the last index element. This is for one rotation, and based on the value of k, the number of rotations will be performed. Finally, after performing the rotations, you can return the same input array and complete the program. This is our solution. Let us try to test this solution and see if it works as expected. The input is 1, 2, 3, 4 and k is 1. Last index is input.length minus 1. Input.length will give us 4. 4 minus 1 is 3. So last index is going to be 3. We are checking if k is equal to 0. K is not equal to 0. So the program goes to the next statement. And the program is going to iterate one time because k is equal to 1 and I is equal to 0 here. We are going to access input of index 3. So index 3 is 0, 1, 2, 3. X is going to have the value 4. The last index is 3 again. We are going to iterate for the first time. Here 3 is the value of y. Here we are accessing input 2 index element, which is 0, 1, 2, that is 3, and we are copying it to the third index element. Here the array is going to be 1, 3 and 3. Then we copy 4 to the 0th index. While testing, we figured out this program has a problem. We need to decrement y, otherwise we will end up in an infinite for loop. We continue with this shifting process, and the next time shifting occurs, the value we end up is 1, 2, 2 and 3, and then we shift again. The value we will get is 1, 1, 2 and 3. Now the value of y is 1, so the for loop will not go further after we decrement it. Finally, we copy x to the 0th index. Value of the array is 4, 1, 2, 3. Then the for loop exceeds, we return this value, and which is the expected output as well, 4, 1, 2, 3. It appears that our solution is working. Let's try to run it in Leet Code itself to see if it is performing as expected. I tried to run our solution in Leet Code, and it appears most of the test cases passed, but one didn't pass. This was the input that was last executed. It appears to be a very large array, and the value of k seems to be 54,944. The program failed with a time limit exceeded error. This basically means that this large array was shifted 54,944 times, and while doing so, the program exited with a time limit exceeded error. Let's see if there is some way we could improve our solution. Let's try to understand the issue with this solution and let's try to improvise it. Reason our solution is failing is when k is a very large number, we are shifting too many times, thereby causing a time limit exceeded error. So fundamentally, we need to avoid this process of shifting too many times. If we try to compare the input and output, after rotating k number of times, the last three elements of the array, since k is 3, comes to the beginning of the array and the remaining elements go to the end of the array. If we had an extra array, that is, if we use extra memory to solve this problem, then our solution becomes way more easier. We will have a new array. We will copy the last three elements to the new array and then we will copy the remaining elements to the last of the array. This way we don't have to shift too many times. But the expected solution says we should not use extra space. That means we need to copy within this array. And if we copy, let's say we copy 5 to the first index 1, whatever data stored in the first index is lost. How could we avoid this loss of data? Our input is 1 to 7. Now I want to copy 5 to the beginning, but if I do so, there is a data loss. Here the value of k is 3. So what I should be doing to bring these elements to the beginning without a data loss means the elements in the beginning has to come to the end. One way we could do this is we can rotate the entire array or reverse the entire array. It's 7, 6, 5, 4, 3, 2, and 1. It looks like we have achieved some part in the expected solution. Now, in the output, 5, 6, and 7 has to be in the same order. We have to reverse the k elements in the beginning of the array. And after reversing k elements, our array will look like 5, 6, 7 and 4, 3, 2, 1. Now the remaining elements again have to be reversed. After reversing the remaining elements, our array will look like 5, 6, 7, 1, 2, 3, 4. Our program will have a reverse operation and then reverse k elements operation and then reverse the remaining elements operation. Let's try to write the solution for this approach. I have written a reverse array function which takes an array input, a start index and the end index, and it basically reverses the array based on the indexes provided. I'm going to store the first element in a temporary variable, then copy the end index element to the start index, and then fill the end index with the temp value. After this, I will increment start and decrement end. That completes our reverse function. We need to call this reverse function in our actual solution. In our solution, we have an input array and then we have k elements and then we have k, which is the number of times we need to rotate. First we can check if k is equal to 0 and return if we don't have to perform any rotation. Then we can add one more condition, that is we can check if the value of k is equal to the value to the length of the array. We don't have to perform any rotation. The reason for this is we basically go back to the same state. If these two conditions are not met, we need to reverse, and in the first scenario we need to reverse the entire array. Start index is 0 and end index is length minus 1. After reversing the whole array, we need to reverse the first k elements 0 to k minus 1. Then we need to reverse the remaining elements k to length minus 1. This is our solution. Let's try to run this solution in Leet Code and see if we are able to get all the test cases passed. I submitted the code that we discussed in the whiteboard to Leet Code and it seems to be working. I had to add one more condition. If k is greater than the length of the array, then the new value of k is mod of k by length of the array. The reason for this is if k is equal to the length of the array after k rotations, the output array is same as the input array. If the value of k is greater than the length of the array, we have to perform rotations only on the remainder of k divided by the length. Let's try to understand this with an example. If k is equal to 12 and length of the array is equal to 5, 12 mod of 5 is 2 and the new value of k is 2. After performing 2 rotations, the output we get will be same as the output if we rotate 12 times. After adding this condition, all the test cases passed. Let us look at the runtime of this program. It is 2 milliseconds and it is 55% better than the other submitted solutions. As far as the memory is concerned, it consumes 63.4 MB and it is 82% better than the other submitted solutions. This is just one way of solving this problem. If you could think of any other solution, please do leave that in the comment section. If you like this video, please hit the like button and do subscribe to this channel for more videos like this. This is an unscripted video, meaning this was recorded as the problem is being solved and it is not pre-planned or scripted before. The reason for doing this way is to help the viewers understand the process involved in solving a programming problem. That is it for this video. See you all in the next video.